a quick recap. In the last session, we discussed about the different types of hypothesis testing, and I believe all of you must be knowing from the last session when to conduct what test, what type of test. So when will you conduct the Z test, hypothesis Z test? When will you conduct T test? How many of you remember this? When will I have to conduct a T test? Just type it in the chat window if you feel shy or if you cannot talk. Population. What is population ESD? Population standard deviation. Okay. So if you know the population standard deviation, what you will do? Yes, Mukilan, you are correct. Okay, if you know the population standard deviation, what test you will conduct? That is what the next question. Your answer is supposed to be like this. The population standard deviation is known, then Z test. If you do not know, then T test. Very simple, right? T. If you do not know the population standard deviation, T test. Most of the time, we do not know the population standard deviation because even though we have access to the population data, we will not be able to get the standard deviation. But there are some occasions you will be able to get the standard deviation. For example, your company has started 2 years back and the volume of the data is not so high. You can get the standard deviation. Let's say HR department wants to conduct some test related to salary, and they started the company almost 4 years back. Now the total employees in your company comes close to, let's say, 6,000 or 5,000, right? So in that case, you can find out the standard deviation. But most of the situations we are what we are facing in the real world scenarios, this one. We do not know the population standard deviation. Most of the time we will be doing the T test only. And also we discussed about two independent sample T test and matched pair T test. So what is two independent sample T test? What is matched pair T test? 1 second please. Yeah. What is the difference? As the name suggests, if you want to compare the means of two different population, we draw samples randomly from the two different population and then we conduct the test. That is what your two independent, as the name suggests, two independent sample test. 1 second. Okay, so that is what two independent sample T test is all about. And the matched pair T test, when will you conduct the matched pair T test? Because this is very important. In the past batches, forget about you. Even the experienced people, they were not able to understand this. When they said, I'm getting confused when to conduct what test. In the case of hypothesis testing, it's pretty simple. If you understand the funda, if you want to compare the pre and post, the effect of pre and post, so in that case, this is important, right? So you will conduct the matched pair T test, right? So dependent sample T test. Okay, Mukilan contribute. Paired T test is specified between time interval like before, after. Okay, we can say, right? So like Mukilan, everybody please participate by typing the answer in the chat window. Let it make mistakes. Only when you make mistakes, you will learn a lot. Right? So don't feel shy or something like that. Okay. Okay, guys. What we will do is, okay, somewhat you are able to recollect at least the big picture, right? So what is Z test? What is T test? What is two independent sample T test? What is matched pair T test? You are able to understand. And we did some kind of lookup in the tables, the log, kind of a log tables, right? Log tables at the end of your book during school time. You can find log books. There you will find the Z table, T distribution table, all the things. Okay, but when you use the packages in Python, like stats package, it has host of statistical functions in it. So with that we can conduct the test. We don't have to find out the critical value, all the things. These packages will help us to get the p-value, and it gives a host of values when you conduct the test. But all we need is all we need to look at the p-value only. If the p-value is less than alpha, we are going to reject the null hypothesis. That's all. So okay, so that's cool. So now what we will do is we will take a look at this assignment. I will help you jumpstart, okay, and you need to break your head and watch my video more than once, and then start practice it. Assignment 1. A labeled potency of a tablet dosage form is 100 mg. As per the quality control specification, 10 tablets are randomly assayed here. Okay, a researcher wants to estimate the interval for the true mean of the batch of the table 95% count. Assume the potency is normally distributed. Data are as follows. So let me just maximize this. If I go here, this is second assignment. Okay. So the data has been given here. So in milligrams, so 98.6, and all these things have been given here. And what is the sample size? N. This is 10. Okay, and this is 10. And they have given us the, did they give the mean value here? No, they did not give the mean value, but they have given the sample data. So 2, 4, 6, 8, 10. So this is 10 tablets are randomly assigned. And if you find out the average is this one, how much you will get? So whatever you get it, that is what your sample mean. And with this you can find out the standard deviation. And your sample size is 10. So you know mean, standard deviation for your sample, and you know the sample size. Here we are not given the population standard deviation. Hence we need to conduct the t-test. Okay, here the at 95% level, confidence level, right, we need to find out whether it is statistically significant or not. Okay, so now the question is, right, so we know the standard deviation, everything. Okay, so now how do we solve this one? Let me just go to the PowerPoint. Let me use something here. Okay. So we know the mean value here. We need to compute the mean. So if you add all the things, you will get how much you'll get the mean. Okay, so mean is going to be let's see, so the mean, sample mean is we use a notation x bar, and it comes around 101.24 mg. If you find out the average for those 10 values, you will get, and the standard deviation is equivalent to standard deviation for sample, we use a notation small s, 2.48. And what is the sample size? N equal to 10. Okay, here we need to find out. So what do we need to find out here? We need to find out the average potency of this one. Okay, so here so how will you find out the so okay, the question is, I'll read out the question one more time. So a researcher wants to estimate the interval for the confidence interval. They want to find out the confidence interval for the true mean of the batch of table with 95% confidence. How will you find out the confidence interval? How many of you remember the confidence interval formula? Okay, so we discussed about the Z thing, the confidence interval. In that case, right, Ci is equivalent to x bar plus or minus Z into sigma divided by square root of n. This is the formula that we used. Here we have used the Z. If you know the population standard deviation, this is the equation to compute the confidence interval. But we do not know the population standard deviation, right? Hence we cannot use Z. We need to do the t-test. In the case of t-test, right? So t distribution, that's t distribution because we do not know the population standard deviation. Here x bar minus tn minus 1. Sorry, this is so guys, don't type anything here. And alpha, okay, here comma alpha divided by 2 cs divided by square root of n, because we do not know population standard deviation, hence we are using the sample standard deviation. The rest is same, square root of n. Alpha divided by 2 is nothing but your z here, but here it is, we are going to conduct the t distribution, x bar minus tns minus 1. So now what is my mean value? 101.24, 101.24, and minus the tn minus, this is my degrees of freedom. How do I find out the degrees of freedom? You need to look at the t distribution table. Since I work in statistics since long time, right, so I know the value for the instead of z, here I am going to use the t, right? So degrees of freedom you need to find out in the t distribution, 2.262 into my standard deviation is 2.48, and divided by, what is square root of n? What is n here? Sample size. What is the sample size? 10 here. Okay, and if I solve this, this is something like, see, ideally the x bar minus tn minus 1 comma alpha divided by 2 into s divided by square root of n is less than or equal to n, and is less than or equal to x bar plus tn minus 1 alpha divided by 2 into sigma divided by square root of n. So what it says here is, this is the one, right? Here, okay, this is not n, this is mu, sorry, okay, this is, what is mu? Population mean. So this is my lower bound, upper bound. So you remember in the confidence interval, right? So you need to find out the lower bound value, and then you need to find out the upper bound value. Once you find out the lower bound and upper bound, so in between the lower and upper bound, somewhere the population mean is falling. The population mean falls anywhere between the lower and upper bound. So how do I find out the lower bound, upper bound? You need to use negatively, x plus or minus, right? So x bar plus or minus. Instead of z, I used t and alpha divided by 2, because we need to find out the confidence interval, right? So two levels, lower bound, upper bound. So sigma, instead of sigma, s divided by n. So this lower bound and this is my upper bound formula, and once you plug in the values here, you will get to know the lower bound value and upper bound value. So with that you can say the true population mean falls anywhere between these two values. That's it. So if you solve this one, you will get how much? 99.47 the lower bound, and the upper bound is, you will get 103.01. You can use your calculator, and if you solve this one, you can see this is tn minus 1. Okay, ideally I should write it neatly. So this is the one. So the population mean falls anywhere between these two values. Okay, so how do I write it? How do I explain it to management? So the batch mean is 101.24 mg with an error of, right? So you need to find out the margin of error. So the margin of error is this part, right? This is your margin of error, z into sigma n. In this case, the t in n minus 1 into s into sigma. This is what your margin of error. So the batch man is with an error of whatever the value you get it here, right? That is what you are. So how much you will get it here? So here 2.62, 2.48. In that upper bound 101.24. This is lower bound. The upper bound is nothing but your 101.24 plus 2.262 into 2.48 divided by square root of 10. So with this lower bound, when I plug in the value, and if I solve this, I can get this one. Upper bound, if I plug in these values, I'll get this value. So with this, what is the mean, the error here? Margin of error minus 177. Okay, the batch mean is 101.24 milligram with an error of plus or minus 1.77 mg. Okay, so now as a researcher, we are 95% confident that the average potency of the batch of tablets is between 90. So with 95% confident, this is a confidence level. I told you the other day, right? So confidence interval is different and confidence level is different. With 95% confidence that the average potency of the batch of tablets is between 99.47 and 103.01. So this is the answer for this one. This is a t-distribution example. In the case of t-distribution, because we do not know population standard deviation, if you know the population standard sigma, then you need to find out the z critical value. Okay, but here we don't have to worry about z because we do not know the population standard deviation. Simply you need to do a lookup in the t-distribution table. In the t-distribution table, you have, see here how many number of sample is there? 10, right? What is the degrees of freedom? Degrees of freedom Tn minus 1 is equivalent to 9. So if you look at the t-distribution table, you have the degrees of freedom here 1, 2, 3, etc. But in our case 9, right? So 9. And here you have an alpha value. So the alpha value starts from something 0.40, something like that, and it will go up, and you will find somewhere like 0.025, because alpha is 0.05. This is what I discussed. Usually the researchers conventionally they use the alpha value as 0.05, and since we need to find the lower and upper bound, alpha divided by 2 we are doing it. 0.05 divided by 2 is 0.025. okay, hence this is my confidence level. Okay, and here these two values, when these two, where it intersects, if you see that in the t-distribution table, you will find 2.262. This is the value at the intersection of these two things. This is my degrees of freedom and this is my alpha level, and this is the one. Okay, so now we can see the 95% confidence that the values or the confidence interval is this one. The true mean falls anywhere between 99.47 to 103.01. So what about the remaining 5%? What about the remaining 5%? Can someone tell me? See, confidence level, if I say 95%, what does that say? See, you remember I was talking about this one, normal distribution, right? So here, so this is what my, this is my confidence interval. The true mean falls anywhere between this lower bound to upper bound. This is my lower bound, this is my upper bound, right? The true mean falls anywhere between these two values, lower bound and upper bound. So what about the rest? This is my, so total area is 1, area under the curve is 1, but here alpha divided by 2 on the left side and alpha divided, so overall alpha is 0.05. So 1 minus 0.05 is my 0.95. So 95% chances that my true mean falls anywhere between these two. What about the remaining 5%? That is what my question. Yes, very good, Mala. Right? So Mala answered correctly. Aruna, may vary, it may consist outlier. Well, it is not outlier, but you are somewhat close to that answer, Aruna. So there is a 5% chance it may not, the true population mean may not fall between these two values. That's what I was telling you with the analogy, right? So if your manager asking you what time you can come tomorrow office, if you say the between 9:30 to 10:30 a.m. I can come, sir, tomorrow. Okay, what is the confidence level? How confident are you that you can make it between these two timings, between these two times? If you say 95%, what does that say? 95% chance that I can reach office anywhere between these two times. There is a 5% chance I cannot make it. This is the risk, right? So this is the risk. There is a 5% chance the population mean cannot fall between these two. So you can tell your management that the this one, the average potency of the batch of tablets is between these two values. The population mean falls anywhere between these two values. The potency, average potency, can fall anywhere between these two, which means there is a 5% chance it may not fall between these two ranges. Okay, so that is the thing. Okay, and the 95% confidence, we are using it here, right? And if they ask you 99% confidence, right, and that is a different thing, but usually conventionally we use 0.05. We'll take a look at the 99%, 1% later point in time. Already I discussed with you as part of the hypothesis testing, right? So when why 0.05 is used, because when you use 0.01, your non-rejection region area size gets increased, rejection region area size gets small. I explained this with a football goal post, right? The bigger the goal post, the chances of hitting the ball is very high, right? If the closer if the goal post is very small, the chances of hitting the ball is very less, very remote. Okay, it should be optimal. It should not be too big, it should not be too small, it should be somewhere between those two. So that is what your alpha, so that's why we use conventionally the alpha value is 0.05. So with this, what you do is you try other assignments, and then you can you can come back with your answers. And next I will jump into another second assignment too. Here you have oddly 6 questions are there. Okay, and 6 questions are there. Let me just this is very interesting one. Exercise 3. So what is type 1 error and type 2 error? How many of you remember type 1 error and type 2 error? Okay, now we will start with this one. The random sample of 100 item is taken. 100 items are taken, producing a sample mean of 49. The population standard deviation is 4.49. We are given the population standard deviation. Now we need to construct a 90%. It is not 95%, 95% confidence interval. We need to construct a 90% confidence interval to estimate the population mean. So what we need to obtain? We need to obtain the estimate of the population mean. We cannot say exact the population mean. We do not know the population mean. We do not know the true mean, but the population standard deviation is given. So hence we can use the z distribution. Okay, and we need to construct a 95% confidence to estimate the population mean. So how do we find out? So we know the sample value. What is the sample here? 100. Sample is 100, and the sample mean is given x bar. We have x bar, and population is sigma. We have given, and we need to find out the 90% confidence interval. Okay, I just work out on this one. In this case, we know the population standard deviation. So what is the sample size? N is equal to 100. And what is the mean value? X bar is equivalent to 49. And standard deviation, population standard deviation was given, the sigma, okay, which is nothing but the sigma here, 4.49 was given. Now we need to find out the 90% confidence interval, not the 95% confidence, 90%. So here z is equivalent to the confidence interval, because we know the population, hence we need to find out the confidence interval for the z distribution. So here minus the z is minus 1.64. See, I was talking about the z value, right? The confidence interval is equivalent to x bar plus or minus z into sigma divided by square root of n. The z is nothing but your confidence level. For the confidence level, For example, if it is a 90% confidence level, so it is going to be, it ranges between minus 1.64 to plus 1.64. Okay, and if it is going to be 95%, that value is different here. So you need to look up the table and you will get it, but you don't have to do the lookup and all. With the statistical package, I will help you out how to get the values. 90%, 95, 99%. For each confidence level, the z value differs. Since they have mentioned 90%, pretty straightforward. 90%, the value if you look at the z distribution table, right, so you will get minus 1.64 to plus 1.64. Okay, so this is the one, and now we know the formula here. With this, we can, if you plug in the values, you can get it. So what is my sample mean here? 49, right? X bar is 49, and I need to find out plus or minus. First, we need to find out the lower bound minus here the 1.64 into, what is this, 4.49 population standard deviation, I know. And what is this, the sample size? 100. So it is going to be 10, right? So 100 is, here 100, square root of 100 is 10. So 4.49 divided by 10, you will get some value. And if you do this one, this is your lower bound, you will get and then you will get, let's say, how much you will get, 48.2. And similarly, you need to find out the upper bound, and here the upper bound is 49 plus 1.64 into 4.49 divided by square root of, it is always a good if you do it manually, if you understand. See, the statistical packages are available. With that, you can find out the confidence interval, everything, but it is always good if you understand the underlying idea behind this, right? So for our lower bound is 48.2, upper bound here 10, right? So so if you solve this, you will get 49.7. Okay, so the confidence interval is now 48.2 comma 49.7 with 90% confident, with 90% confidence level. Okay, so here so the population mean can fall anywhere between 48.2 and 49.7 with 90% confidence level. So how do we interpret this? If you repeatedly draw several samples with sample size 100, there is a 0.95 probability that the confidence interval will contain the true value of the population mean. This is how you need to interpret this one. I just write it here. If we repeatedly draw, see, this is another question. You have taken one sample, you have taken one sample, that sample contains 100 values in it, right? So you randomly sample the data, and it has, so likewise we can draw any number of samples. For this sample, this is the mean. What is the assurance that if I draw different samples, the mean value will not be same for different samples, right? For example, I am going to randomly sample another 100 records or observations from my population. For that 100 values, the mean may not be same. Now the question is, how confident are you that if you draw multiple samples with the same sample size 100, so what is the probability that the above confidence will contain the true value of the population mean? Okay, so here if you repeatedly draw samples with a sample size n equal to 100, there is, what is that? There is, I can say, let's say here I'm going to say the 95%, 0.95, so not probability. Okay, there is a 0.95 probability that the obtained confidence interval will contain the value of the population mean, value of the population mean. So now the question is, sample to sample, the mean will vary. So now how can you say with one sample, you see with this one sample, you obtain the confidence interval like 48.2 and 49.7. So the population mean, the true mean can fall anywhere between these two. That is what we have obtained. How can you generalize something? Like if you repeatedly draw samples with samples n equal, there is a point that the obtained will contain the value of the population mean. If you draw multiple samples, more than one sample, sample to sample, the mean will vary. Obviously, when the mean value changes, the confidence interval also changes, right? How can you make a statement that 95% probability that the obtained confidence will contain the value of the population mean? So here, there is a central limit theorem, right? So that is where the central limit theorem comes into picture. You need to remember the central limit theorem. As per the central limit theorem, the sample mean can be approximated to the population mean as per the central limit theorem. The sample mean, I'll write it here so that when you watch the video again, the sample mean can be approximated. I need to improve my handwriting skills. Approximated to the population mean. As per the central limit theorem. That is the reason why we don't want to break our head, or we don't want to do heavy lifting by drawing multiple samples and finding out the confidence interval for each samples. We are not doing that because the sample mean can be approximate to the population mean as per the central limit theorem. So you need to remember this thing. This is very, very important. Okay, the approximation. Okay, it is not the exact value. So that is the reason we are giving the interval. There is a 95% prob. There is a 0.95 prob, not percentage. There is a point, or you can say 95% chances that the obtained confidence interval for that sample will contain the value of the population mean if you draw samples, if you repeatedly draw samples with sample size n equal to 100. So you need to remember this statement. Okay, so that's the reason why this assignment is very important. I am solving this on your behalf so that you should be able to solve the remaining assignment. Okay, and what is type 1 error and type 2 error? What is type 1 error and type 2 error? How many of you remember the type 1 error and type 2 error? I just go to the second one. The same thing, you can find out the confidence interval for that. So you don't get scared of the big paragraph. Okay, all you need is the sample mean and find out if the standard population standard deviation is available. Okay, yeah, right, and find out the sample size. If it is a t distribution, you need to find out the n-1 t n-1, the degrees of freedom, right? So that's all. Okay, so this is the thing. Write the null and alternative hypothesis and identify type 1 and type 2 errors in the following scenarios. An innocent person is sent to jail. For this, you need to write the null and alternative hypothesis. And for the next one, so what is the null hypothesis in this case? This is very, very important thing. Okay, and what is the null hypothesis here? Innocent person is sent to jail. The null hypothesis, the person is innocent, right? The person is innocent. The alternate hypothesis, opposite. The person is guilty. So I'll just write this one. So what is the problem? First one. The first one is an innocent person. An innocent person is sent to jail. Okay, what is the null hypothesis? We use the notation H sub 0. This is null hypothesis. The person is innocent. We are assuming that person is innocent, because this is the statement, right? The innocent person has been sent to the thing. And what is the alternative is? It is opposite. The person is culprit or guilty. This is how you need to write the null hypothesis. So what is the actual result? What is the actual result here? The person is actually innocent, but is sent to jail. But he is sent to the jail, right? So why though the person is innocent, and why he has been sent to jail from the statistics point of view, the null hypothesis. See, in this case, the null hypothesis is actually true, but they accepted the alternative hypothesis by rejecting it. So falsely rejected the true null hypothesis. Falsely rejected the true null hypothesis. Guys, can you tell me what is P is less than alpha? What we are going to do? Let me see how many of you remember it. If you don't remember it, then there is no point in continuously attending the training. You need to take a break and revise all the topic and then come back. What is P is less than alpha? I told you, right? What is P is less than alpha? When P value is less than alpha, what we are supposed to do? We discussed about critical value method, and also we discussed about the P value method. I told you the p-value method is the one is used, right? So when you conduct any statistical test using the statistical packages in Python or R, it will give you the p-value along with the critical value, other thing, and degrees of freedom, all the things. If the p-value is less than alpha, what does it say? No. Mala, you mentioned the opposite thing, right? So Nalaibash, okay. Karthik, accept, no accept, right? P is less than alpha, reject the null hypothesis. Guys, this is very important. Please remember, reject H sub 0. Null. This, if you want to memorize it, please memorize it. Even if you go to restroom, please remember it. Yes, P is less than alpha, reject null hypothesis. This is a simple tip I will give you. No matter what kind of the statistical test that you conducted, you conduct any type of statistical test, like a Shapira will test, or Mann-Whitney test, Levin's test, a lot of statistical tests are there. You don't have to care about the name, the output only you need to care. If you find the p-value is less than alpha, alpha we know very well, already I told you, it should get registered in your mind, alpha equal to 0.05. But again, when you work with the company, if they ask you to use the conduct the hypothesis test, then you need to check with them once again. Can I use alpha equal to 0.05, or can I use alpha equal to 0.01, or can I use alpha equal to 0.10? So which means that, so what does it say? 0.01 tells you there is a 1% risk. If I tell you the confidence level is 95%, what is the remaining 5%? That is what your alpha, the risk, right? You are going to take 1% risk here. Here, 1 second. So alpha equal to 0.90. Okay, why it is not coming here? Okay, alpha equal to 0.10, there is a 99% confidence, and 0.01 means 90%. Guys, please don't forget this. So 1 minus 0.01, how much you will get? 0.90, right? If you have to tell this in percentage, 9. So similarly, 1 minus 0.10 is equivalent to so the 0. The 0. This is 0.99. Sorry, this is 0.99, 99%, and this is 0.90, which means 90% confidence. And if you say 1 minus 0.05, so this is going to be your 0.95, which means 95% you are confident. Remaining 5%, that is what your significance level or the risk which you are going to take. Okay, if I use alpha equal to 0.05 and conduct the test, there is a 5% chance the population mean cannot fall between this, and there is a 5% chance that the whatever the thing that are rejected is not correct, right? So that is what it says. So in this case, the statement was given very clearly: an innocent person is sent to jail. How do you write the null and alternative? This is how we need to write the null and alternative hypothesis. And if you reject the true null hypothesis, this is true null hypothesis. Actually, this person is innocent. That's it. Was it says, right? And mistakenly you rejected the null hypothesis, true null hypothesis, and you are going to consider this person is guilty. This is called your type 1 error. Rejecting the true null hypothesis called your type 1 error. So why we are rejecting the true null hypothesis? Let's say your p value is 0.001, you are getting something like that, and if the alpha is 0.05, you are going to compare 0.001 is less than 0.05, you are going to reject the null hypothesis. Since the p value is less than your alpha, as per this, you are going to reject it. But right, so when you reject this one, you are making a type 1 error. Okay, and next scenario is, now you understood, right? Falsely rejecting the true null hypothesis is called your type 1 error. So in Tamil, if you say, how will you say? I guess all of you are Tamil except Aruna, okay? And Aruna and others. Yeah, so most of you are Tamil. In Tamil and Telugu also, I'll tell you, don't worry. See, okay. See, தப்பு இல்லாததை தப்புன்னு சொல்கிறது தப்பு தான், கரெக்டாக? தப்பு இல்லாததை தப்பு இல்லைன்னு சொல்கிறது, தப்பு இல்லாததை தப்புன்னு சொல்கிறது தப்பு தானே? ஸோ ஆக்சுவலி இது தப்பு இல்லை இல்லையா? இட் இஸ் நாட் அ மிஸ்டேக், இஸ் ஆக்சுவலி அ இன்னோசென்ட், பட் யூ ஆர் ரிஜெக்டிங் ஜஸ்ட் பிகாஸ் யுவர் p value is less than alpha, but actually he is innocent. You are not supposed to reject it. Mistakenly or falsely rejected the true null hypothesis, we call it type 1 error. Okay, and the next one is the other what is the other statement? The second statement is, the manager sees some evidence that stealing is occurring. Manager is actually saying somebody is stealing, but lacks enough evidence to conclude the theft, and he decides not to fire the employee. So how will you write the null and alternative hypothesis in this case? So employees conclude the theft, and here what we are doing is, we are assuming that employee is not stealing. Always we think positively, okay, and simply we think positively, and we say so in that case, manager is actually saying somebody is stealing, but you are assuming that the employee is not stealing here. Employee is not stealing in your retail shop. What is the alternative hypothesis? Here the employee is stealing. The employee is stealing, right? So here, so what is the actual result? The employee is actually stealing, but manager does not have enough evidence to. So what do you mean by enough evidence to conclude the theft? So actually he is supposed to reject this null hypothesis, right? He is supposed to reject this null hypothesis, and you need to conclude he is stealing, but he does not have sufficient evidence as per the test. Can you tell me what do you mean by not having sufficient evidence? What do you mean by not having sufficient evidence? P is less than alpha, right? Here you are getting p is greater than alpha. If the p is less than alpha, what you will do? All of you please type it in the chat window. Please, you are not concentrating here. That is the problem, okay? P is less than alpha, what are we going to do? Please type it in the chat window. Guys, this is what we discussed, right? P is less than alpha, reject the null hypothesis. Please, all of you type it in the chat window. Please wake up. Reject the, not the test, reject the null hypothesis. Don't say test, reject the null hypothesis. That is the term you need to use it. Reject the h sub 0. Yes, very good, right? So reject null hypothesis. P is less than. If it is greater than alpha, what you will do? P is less than alpha, reject the null hypothesis. If it is greater than alpha, what he will do? Yes, accept null hypothesis, that is correct, but in statistics you are not supposed to say accept null hypothesis. Fail to reject the null hypothesis. Failed to reject null hypothesis. Failed to reject the H sub 0, which is nothing but my null hypothesis, which is actually in general in English language, right? Accept the null hypothesis. But you are not supposed to use this term when it comes to study. Instead, you need to say because lack of evidence. Because my p-value is greater. Somehow, when I do this, p-value is greater than alpha. Hence, I fail to reject the null hypothesis. When you fail to reject the false, is this a true null hypothesis? No, it is a false null hypothesis. It is a false null hypothesis. Right? So, fail to reject the false null hypothesis. Fail to reject the false null hypothesis. This is called type 2 error. Okay, a person is not having COVID, but he is actually having COVID. We have seen that, he is suffering fever, all the things. We could see the symptom, but we are assuming that he is not having COVID. And in this case, you are supposed to reject, right? A person is actually having COVID, but you fail to reject the null hypothesis. That is your type 2 error. And here you are saying, is a false negative, right? You are saying false negative. Here you are saying false positive. Correct? False positive. Here you are saying that you falsely rejected the true null hypothesis. Falsely rejected the true null hypothesis. True null hypothesis, positive, right? You saying that this person is innocent. Let's say in this case, person is healthy, but you are rejecting and saying the person is having positive, COVID positive, right? False positive, false negative. You can apply different scenarios also to understand your thing. Okay, that's why I used the COVID example here. So falsely rejecting the true null hypothesis is also wrong, and falsely or fail to reject the false null hypothesis is also wrong. So this is called false negative, and this is false positive. Okay. Okay, so true negative, correct. Sorry, type 1 is false positive, and type 2 is true positive. Yes, correct. Type 2 is type 2 is it is true negative. No, false positive. Wait. I will just give me a second here. I just am getting. The COVID false positive and false negative, right? Yeah, it's correct only. What I mentioned was correct only. It's not true, right? So you can go and check it in Google also. Let me just go and check it here. Use the same thing. It's false negative, right? Actually, he is having a COVID. False positive and false negative. Type 1 and type 2 error, right? So false positive and false negative. Look here, even in the case of binary classification, we are going to use this one to conduct the test. So to evaluate the model performance, okay? And false positive and false negative, right? So this is the one. So false positive and false negative. Type 2 is yes, false negative, and type 1 is false positive, right? That is what here did they give? Yeah, type 1 error rate, right? So the type 1 error rate, error checking the condition, and the probability of positive result being false, and false negative error, right? So type 2 error. False negative is type 2 and false positive is type 1 error. It's correctly, I mentioned correctly, okay? So hope you understood with this one. It will be slightly confusing. Don't get confused. But for that reason only, I told you to apply the COVID or cancer, right? So this is very critical, the type 1 and type 2 error. For example, if you send an innocent to prison, if you hang him, it is a very, very dangerous one, right? You are punishing an innocent guy. Punishing an innocent guy is also problematic. And if you don't punish a guilty guy or criminal, right, and if you simply accept the person is innocent though he is a murderer or criminal, what will happen? You are leaving this guy to walk in the street. The criminal, you are allowing the criminal to walk in the street. So hope you understood. Falsely rejecting the true null hypothesis and fail to reject the false null hypothesis is also problem. So the falsely rejecting the true null hypothesis is called your type 1 error rate. It is also called the false positive, and the falsely fail to reject the null hypothesis, false null hypothesis, fails to reject the false null hypothesis is called your type 2 error, which is your false negative. Okay. Wrongly saying that the person is not positive. Positive in the sense he is actually COVID patient or he is a criminal, but you are saying no. Falsely you are saying no, he is not a criminal, right? So you remember type 1 and type 2 error. Anyhow, we are going to talk about the type 1 and type 2 error when I cover the logistic regression, the classification models tomorrow. Okay. Fine. The next one is I will jump into another test now. Okay, we have discussed enough about the hypothesis testing, all the things. Hope today's session will be a refresher, and make sure that you are watching my video before you attending my next session. Okay, make sure that's a good practice always. Okay, so anyhow, I will just use my site. We have another test called Anova test. Look here in my website, you'll find the video as well as the material. Wherever you find material, that is a PDF file. I just click on it. Anova testing with case study. Okay, so now we are going to discuss a different type of test, it is called Anova test. Anova test. What is Anova test? Anova stands for analysis of variance. Analysis of variance. That is called your Anova. Anova. For example, I have something like let's say I have something. Let's say I ran a survey with 3 different retail stores like Walmart and Target, and I'm going to Amazon. Okay, I just I put my staffs just in front of these malls in USA, and they are randomly calling the customers. Those walk out from these shops, right? These guys, our guys, should go and talk to them and run a survey. They're going to ask, how much amount you send. So one guy says, he spent $40, another guy says $60, other guy says, today I spent $100. And Target also, he says $50, $60, and something like that. Amazon also, they are telling. Okay, so here we wanted to find out the amount spent, the average amount. See, end of the day, you take the average, right? This is your sample. The average spend is, let's say, 200 divided by 3. Let's say, you are going to get somewhat $65, and here you get something like, you have something like 60 and 100, 210. So it's $70, and here you get Amazon customer. You spoke to them. You took the average, the X bar, and I say X1 bar, X2 bar. This is sample 3. Here let's $69. Now, if I wanted to compare, if you want to conduct the if I want to conduct more than two groups, or if I want to find out are there any difference in the mean value of the samples for more than two groups, we need to use analysis of variance. In the case of two sample independent t-test, two sample independent or two independent sample t-test, we have used only two samples. As the name suggests, the samples we have drawn from two different populations. Those two populations are supposed to be independent. There should not be any dependency between the population. If you, like I said, male and female, right? So male is a separate population, female is a separate population. You are randomly sampling the data from male population and randomly sampling the values from your female population. Those two samples are independent. It is not dependent. Male is different, female is different, right? So in that kind of situation, we have a test that is readily available, two independent sample t-test, using which we can conduct the test. Okay, but in this case we have more than two samples. All these samples are independent from one another. This is the Walmart customers are different, Target customers are different, Amazon customers are different, because you ran a survey from three different companies or retail shop. Okay, maybe this customer is buying here. Let us not get into that confusion. See, we ran a sample from three different retail chain or retail shops. If you want to conduct, or if you want to find out, or if you want to compare in all these three groups means are same, or if you want to compare more than two groups means are same or not, then you cannot use two independent sample t-test. I will tell you why. Instead, you need to use analysis of variance. If you want to compare the means across multiple groups or more than two groups, then you need to use Anova test. You cannot use two independent sample t-test. You might be asking this question, sir, can I take these two samples? These two samples are independent. I will run one independent t-test, two sample independent test one time, and then I am going to take these two samples and I am going to run the independent t-test one more time, and finally I am going to take these two samples, Walmart and Amazon, I am going to conduct. So in that case, how many number of tests you need to conduct? How many number of hypothesis tests that you need to conduct? See, there is a limitation with the independent t-test, right? You can use only two samples. But if you have to run if you want to run the hypothesis test, the two independent sample t-test, if you have more than two groups, how many number of times you need to conduct the test? These two samples you need to conduct the hypothesis test once, and then you need to conduct one more test, because you need to compare these two sample mean, and then you need to compare this. So totally you need to conduct three tests. So that is a painful thing, right? So if you want to compare this using this, if you want to conduct, if you conduct the independent sample t-test, two independent sample t-test, you need to run the test 3 times. Okay, so this is a painful thing. So up until now, we have done the comparison so we have been comparing two population using independent sample t-test and paired t-test, matched or dependent. Okay, and with t-test we can compare up to two populations only with t-test. Remember this. With t-test we can compare up to two populations. So in my case, I have three populations, right? I want to compare three populations. For that, I have sampled the data from three different populations. How can I do that? So in that kind of, anything more than two groups, you need to conduct the Anova test. Anova stands for analysis of variance. So Anova is used to test whether the means of more than two quantitative populations are equal. More than two quantitative populations are equal, or more than two groups. If you want to compare the means, then you need to use Anova test. Now the question is, why can't I use two independent sample t-test? So why can't I use t-independent sample t-test? That's what, you need to conduct 3 times. Okay, let it be there, because in the past they were using, the researchers or scientists or the statisticians, they were using two independent sample t-test to compare the means of more than 2 groups in the past. Afterwards, someone came up and he introduced something called Anova test. With Anova test, you will not run into any issues. What kind of issues that you will pose it when you conduct two independent sample t-test? The disadvantage is, look here. So to compare these two sample mean, right? So you need to define the null. So x1 bar equal to x2 bar. So both of them are same. This is what your null hypothesis. Opposite is the amount spent by the customers in Walmart and Amazon is not same. That is your alternate hypothesis. This is Walmart, this is Amazon, this is Target. So again, you need to conduct another test, hypothesis test, to compare these two. So x1 bar is equal to x3 bar. Let's know this is your Walmart, this is Amazon. So both the customers, or the Amazon customers, this is my Target and Amazon customers, the average spend is same. We assume that. And again, so this one and this one we need to compare, and this one and this one we need to compare, and this one and this one, the x2 bar equal to x3 bar. For each test, you need to use alpha value. Right, so alpha value, alpha is equal to 0.05. Right, so here in this case, since you are using for each test alpha equal to 0.05, what happens is your and also, right, the confidence level is for each test 0.95. So 0.95 into 0.95 into 0.95, you get 0.857. Your confidence level goes down if you conduct 3 tests by comparing this one and this one and this one and this one and this one, this one. For each time, for each test, you need to use alpha, isn't it? If you without alpha, how can you use it, right? So since you are conducting 3 tests using 2 independent sample t-test, your confidence level goes down and your risk is increasing it. 1 minus, if you subtract this one, this is what your risk level is. Also your risk level goes high, your confidence level goes down. That is the reason why we cannot use 2 independent sample t-test. And also it is time consuming, like Mukilan mentioned, it is time consuming. You need to conduct 3 different tests. But in the case of Anova, only 1 test is enough. You don't have to run 3 tests, only 1 test is enough. Fine. Here in the case of Anova test, there are different types are there. Okay, so one-way Anova and two-way Anova. Within this two-way Anova, we have two-way Anova without replication and two-way Anova with replication. And the next one is three-way Anova, and we have something called Ankova, Mankova, Manova, and Mankova. So the Ankova stands for analysis of covariance. This is multivariate analysis of variance. This is multivariate analysis of covariance. You are not going to look at all these things. It is not required. If you know what is one-way Anova, two-way Anova, that is more than sufficient. Okay, and what are the assumptions it makes in the case of Anova test? The population from which the samples were obtained must be normally or approximately normally distributed. So you are obtaining these samples from 3 different populations, the Walmart, Amazon, and Target. These 3 shops are completely different, but the samples whatever you obtain from these 3 different populations should be approximately normally distributed, and the samples must be independent. Obviously, this sample you have drawn from Walmart, this sample you have drawn from Amazon, this sample you have drawn from Target. The variance of the population must be equal. This is not always possible. Okay, you can simply ignore that. So now, how do you define a null hypothesis in the case of Anova? Simple, right? So the population 1 mean is equivalent to the population 2's mean and population 3's mean. Okay, the alternative hypothesis, at least 2 of the means are not equal. The amount spent by the customers in Amazon, Target, and Walmart, the average amount spent by the customers of these three retail shop are same, we assume that the alternative is not necessarily Amazon customers spent whatever the amount they spent in Amazon is not equivalent to Walmart, and whatever the amount spent by the Amazon customer is not equivalent to Target. Need not to be, okay. At least two of the means are not equal. For example, these two are same in the alternate hypothesis, but mu2 is not equal to mu3, right? In that case also, right? So we can use this one, okay, the alternate hypothesis. You can define it like this. In the case of t test statistic, z test statistic, we have used formulas. What formulas that we used in t test statistic and z test statistic? Let me see how many of you remember it. It's a very simple formula. How many of you remember it? So guys, you are very particular about completing the training, right? So t statistic is equal to x bar minus the, what is that, population mean and hypothesized population mean divided by small s divided by square root of n, right? And z test statistic value is x bar minus the hypothesized mean divided by sigma divided by square root of n. This is what the z test statistic and t test statistic. That is what we discussed. See guys, there is no point in being punctual, right? And regular. But here, in the case of Anova, instead of using z and t test statistic, this formula, we use something called f statistic. And in some people they call it f test. The Anova test they call it the f test. Okay, so we are going to use different formula in the case of so test statistic is different in the Anova. Okay, so the next one is okay. Let me do one thing. So why it is hanging here? It is not showing here anyhow. So you need to refresh it. If you don't see anything, right, click on refresh. Look here, you need to click on this button, right? So this icon, refresh. When you click on it, it will take some time and refresh it. Okay, so if you find something blank here, that means it will take some time to buffer it. It depends on your internet bandwidth also. Okay, and here it is not showing. I will write it here, not a problem. So here ideally if I get it, it will be good. Let me refresh it. It got refreshed. Look here, I got it. Let's say I have three different stores. Okay, instead of comparing three different retail shop within the same retail shop, let's say mine is ABC retail shop, and but I have three retail chain. One is in Bangalore, one is Chennai, other one is in Pune. And what I do is I randomly sample the amount spent by the customers, and each store I took the average. Okay, fine. But each store the mean is different, right? So now I need to compare the amount spent by the customers in three, all these three stores are same or different. Okay, so we need to find out that one, right? So here in this case, let us say the x1 bar, the 47.75 is the mean. Let us assume that this is the population mean. All these three things put together, the population mean is 47.75. But the store one, the sample mean is exactly falling on this place, okay, the population mean. Okay, but here the x2 bar, this mean is way less than 47.75, whereas this one is way more than this one. How far each store's mean is away from the population mean? Okay, that is what we need to find out. And there are situations, right, this population is completely far away from this mean. That means this sample is not coming from this population. Okay, so to understand the formula that you need to use it to find out the F statistic, type 1 or type 2 error. So we see, let us not jump in. First let us go step by step. Okay, so here the x1 bar is falling exact in the grand mean, and so you need to find out the distance from grand mean. So how far each group's mean. Store 1 mean is falling exactly here, and store 2 mean is falling far away from this, and store 3 mean is falling far away from the grand mean. So distance from grand mean, how far, the variability between among the means. Okay, here in simple term, distance from the grand mean, how far each group's mean is away. The numerator, see how the f statistic needs to be computed. Okay, the formula for this is very simple one. How far each group mean is away from the grand mean, and within sample spread, and with, so let's say this is the mean is here for this group, and so for this group the mean is, very well, the mean is there in the middle, right, in the case of normal distribution. How far each values away from within this group mean. So what is the mean of this group? x2 bar. So let's say you have value here, you have value here, this is falling in the middle. How far this value is away from this? Within this sample, what is the variation? How far each group's mean is away from the population mean. So this one divided by this one. Look here, the variance between and variance within. So between divided by within, right? So within the sample, what is the variation? Between the group, what is the variation, right? How far each group is away from the grand mean, that is what I call as a between, and within the group, how far each value is away from the each group's mean. So between divided by within, very simple, isn't it? So the grand mean is nothing but variance between and variance within. This is what your f statistics. You understood, right? In the case of Anova test, we use f statistic. So the f statistic, how we are deriving it, this is how we are doing. How far each group, each store mean is away from the overall mean, and within each store, now what is the variability? So between divided by within is nothing but your f statistic. Okay, I am not going to discuss that this now at this moment. You will get confused. So what I am going to do is, I just go to this PowerPoint, not this one. Okay, here I just go here because the formula, everything is available here. Let's take this simple case study to understand the Anova test. Let's say in my retail store, as I told you, I have 3 retail chains. One is in Bangalore, other one is in Chennai, and other one is Pune or Hyderabad. Okay, Hyderabad, Chennai, and Pune. Okay, what I do is, I want to find out, does the amount spent by the customers in all the 3 locations are same. Okay, I want to find out the average amount spent by the customer is same across all the group. So here, this is let's assume that this is Bangalore, this is Chennai, and Hyderabad. Okay, so in this case, we need to randomly sample the data from this region and randomly sample this, you can do it. So what I do is, instead of doing this way, okay, let it be there. This is my Chennai, and this is my Bangalore, Chennai, Bangalore, Hyderabad. Okay, Chennai, Bangalore, Hyderabad. What I do is, in my shop, in my retail shop, you have the shelf, right? You have the racks are there. In the racks only they kept all the products, all the items. See, if you go to any retail shop, right, I don't have to tell you, but I want you to, shelves are there, right? So this is my, and you have the front shelf, and you have the bottom shelf. So in the top shelf, they keep some items. Okay, they keep some items in the here, right? So they keep some candies. What is candies? In USA they call sweets as candy, chocolates and all the things, and cookies are nothing but biscuits. Okay, in US they use this term, cookies, nothing but biscuits, and this is your chocolates. and the middle one you kept some milk or something like that, okay. And this is your front shell, this is your top shell, or you have bottom shell. This is your bottom shell and this is your top shell, this is front shell. As soon as the customer walk into your retail shop, you have front shell here, so as soon as they walk in, it should attract them, okay. You kept something here. So now you wanted to understand what drives the sales. Does keeping the items in different places of the shelf has any influence on the sales? That is what you need to understand as part of this case study. Okay, so for that, what you do is you call the managers. Okay, you call the 3 different location managers, retail store manager. You call, let's say Mukilan. He is Chennai manager, retail, and here this is Bangalore. I call Karthik. Okay, Karthik is the manager. So here Mukilan, Karthik, and here Aruna, right? She is the one Hyderabad. Okay, and what I do is I own these 3 shops. I am the owner of these 3 shops, but each shop I have a manager, store manager, and I call Mukilan. I'll tell him, hey, Mukilan, keep all the cookies in the top shelf. Cookies or biscuits, keep it in the top shelf. Don't keep it in the bottom shelf. Keep it there. And I'll call Karthik and I'll tell Karthik very clearly, hey, in this is my Bangalore office. Karthik is there, Bangalore store, and I tell Karthik, hey Karthik, keep all the cookies in the mid shelf. And I call Aruna and I instruct her very clearly, keep all the cookies in the front shelf. Okay, but okay, so I gave them this instruction very clearly, and at any cost you need to keep all the cookies or biscuits in the top shelf in Chennai, and all these biscuits you need to keep it in the middle shelf in Bangalore, and in Hyderabad, Aruna, I strictly instructed, keep all the cookies in the front shelf. And then I gave another instruction to all these 3 managers. I'm saying that at any cost, you are not supposed to shift the position of the cookies. It should remain at least for the next 5 to 6 weeks or 5 weeks. It should remain in the top shelf. And in Chennai, in Bangalore, it should remain in the middle shelf. In Hyderabad, it should remain in the front shelf. You are not supposed to change the location. You are not supposed to change the price also during the 5 weeks time. Understood? This is the condition. I put the condition very clearly because I want to understand, does keeping the items in the different position of the shelf does have any influence on the sales? Will it increase the sales or will it decrease the sales? I want to understand that one. So okay, now all these managers, they agreed, and so they agreed for these three rules, and they kept in Chennai, Mukilan, he kept all the cookies in the top shelf. What I do is each week I call each manager in all these 3 locations and I take a note. So how many items you sold, how many cookies you sold in Chennai, Karthik. So he says Mukilan, okay, he says 2, and in Bangalore, Karthik gives me 10 middle shelf when I kept it. So I was able to sell 10, sir. And Aruna, she says in Hyderabad, I kept all the cookies in the front shelf. The first week sale is this much, second week sale is this much, third week sale is this much, fourth week, fifth week. I noted down everything. I call each and every manager every week and I ask them how much they sold, the cookies, the biscuits, right? So units, number of packets. And then when I take the average, I get 4. When I get average here, so 8 and 13. And this is my variation. Okay, this is my variation. I'll tell you. So how will you find out variation? How many of you remember variation? Variance. We discussed variance as part of descriptive statistics. What is standard deviation? Sigma. Sigma squared is your variance, right? So you need to subtract the mean from each and every value. So 2 minus 4 whole squared, 3 minus 4 whole squared, 7 minus 4 whole squared, 2 minus 4 whole squared, 6 minus 4 whole squared. Right, and then you need to add the value and divide by n, you will get 22. So this is what this is how we compute the variance, guys. This is very important. There is please revisit. I would suggest you to take 1 day break, weekend, Sunday, and you revise it. That's how other batches, the from the target, it's not target. Tiger Analytics, the analytics company, right? All the guys, top guys, they came and they said we want a break. Okay, so what is variance? Remember this. Okay, 2 minus 4 whole square, 3 minus 4 whole square, 7 minus 4, and 2 minus 4, 6 minus 4 whole square, right? So that is what your variance. That is how we got this value. So we computed the mean for each and every store. I computed it, and also I have computed the variance also here. And next step is I am going to define the null hypothesis and alternative null hypothesis. And next one is I just simply copy pasted this one into next slide. Top shell, mid shell, the same values. Here also the copy paste is the same thing. And here what I do is forget about blue dot. Okay, this is something nonsense. So I put all the values 2, 3, 7, 2, 6, all the store values here. Okay, 2, 3, 7, 2, 6, and it's a population. If you add all the values, you'll get population, right? What is my population mean? And what is my population variance? Subtract 8.3 from each and every value and square it, you will get this one. Okay, so that is what this one. Now we need to use this formula. Total sum of squares is equivalent to sum of squares within groups, sum of squares between groups. Sum of squares within groups. So we know this one, right? So within groups, 22 plus 18 plus 14. So which is nothing but your 15. So we got this value. So this is the formula, right? Sum of squares within groups, sum of squares between. Now we are able to obtain the sum of squares within groups. So this we have already computed. 22 plus 18 plus 14 is equal to 54. Good. Next one is sum of squares. Sorry, this is within groups. And next one is between groups. We need to find out between groups. In this case, what we are doing is it is slightly different. So we are subtracting the each group mean from the overall mean. 4 minus 8.3 and 8 minus 8.3 whole square plus 13 minus 8.3 whole square, and whatever you get it here, you will get something like 40.7. Sum of squares between groups. This is how you need to obtain the value for the sum of squares between groups, and you need to multiply this by 5. Okay, what is 5? 5 is nothing but number of your sample size. Okay, and you will get 203.3. So you got the value for sum of squares within groups, which is nothing but 54. Sum of squares between groups, you got 203.3. If you add these two, you will get total sum of squares. It should match with this value, 257.3 plus 203.3 and plus 54. The sum of squares within groups I already did it, and sum of squares between groups, so we have computed like this, 203.3. And why should I multiply this by 5? Yes, that is the formula. Okay. Next, what I should do, you remember the F statistics. Sum of squares between groups divided by sum of within groups. This is within groups and this is between groups. Okay, so sum of squares between groups, how far? You remember that the image. So this is my grand mean. How far each group mean? X1 bar is away from this one, X2 bar. So let's say this is X2 bar and X1 bar, and this is my X3 bar, right? This is on the numerator. So how far sum of squares between groups divided by sum of squares within groups. Within each group, how far each value is away from the mean, right? The same thing, but only difference is this is your F statistic. Okay, this is your F statistic. Sum of square between groups and divided by within group. Okay, so between divided by within. You need to remember this. So when I talk about this, you need to picturize this one. So which one? You need to picturize this one. Between, how far each mean is away from the grand mean, how far each mean is away within each group, right? So between divided by within. So that is the formula, right? So but here what we do is between divided by degrees of freedom, variance between divided by degrees of freedom, and variance within divided by degrees of freedom. We put the extra thing, that's all. So how do you find out the degrees of freedom? Here sum of squares between groups. Here we have 3 groups. 3 minus 1 is 2. That is what the degrees of freedom. Okay, and within the group how many values are there? So 3 into 5, 15. Sorry, you need to add all this 54, right? Sorry, within group already we computed 54 divided by the degrees of freedom is 12 in this case. Here 15, right? So for each group 1 1. So degrees of freedom 1, degrees of freedom 2, degrees of freedom 3. So 5 minus 1, 4, and 5 minus 4, 4, and here 3 4s are 12. Got it? Degrees of freedom, and is equivalent to, you will get 4.5. This is my sum of squares within group. This is my sum of squares between groups. So this one divided by this one. Okay, and how much I get? So look here, 101.667 divided by 4.5. This is my F statistic value, and if you solve this you will get 22.59. So here finally I just rewrote this one here, and F statistics with the degrees of freedom 2 and degrees of freedom 12, we get the value 22.59, and we need to find out the critical value for this. Okay, and you need to look at the critical value in the table. Let me just see the table, I put it here. Okay, what I will do is I will show you why to worry about that when we have the Google. Here I just say chi-square distribution table. Chi-square distribution. So 2 comma, how much we got? 2 comma 12, right? So 2 in the numerator. Okay, this is somewhat 3.89, right? So we need to get 3.89. So 2 comma 12. But here it is not showing the correct thing here. Let me just this table is not the correct one. 2 comma 12. So here it should show the numerator degrees of freedom and the denominator degrees of freedom. That is the table you need to use it. It is F distribution. Here they would have mentioned very clearly here degrees of freedom on the numerator and denominator. Yeah, F table, it is actually F table. Look here, if I go here, so how much we are getting it? 2 comma 12. It is not showing. Yeah, the numerator is 2 and this 12 is okay, here 2 and 12 like this 9.39. so F table of critical values for significant 0.10. this is 0.010, and here okay, I did not get the table. Let me just go here and see my website. In that website PDF file I already put that one, I guess. Okay, I will show you in tomorrow's session. So you will have something called numerator degrees of freedom and the denominator degrees of freedom. At the intersection you will find 3.89. This is my critical value, okay. And here, what is the F statistic value? 22.59. Now we need to check whether 22.59 is greater than 3.89 or less than 3.9. The chi-square distribution is something, sorry, not chi-square distribution, Anova distribution is something like this, okay. It is not normally distributed, it's kind of, the positive skew. And this is my critical value, 3.89, obtained by looking at the chi-square distribution table. So here my F statistic value was 22.59. Look here, 22.59. Since the 22.59 is greater than 3.89, it is falling in the rejection region area. Hence, we reject the null hypothesis, and we are going to conclude that the the average sale across all these three locations is not same, is statistically different. The average sale across these three stores are statistically different, which means the sale is not same. By keeping the items in different position of this shelf, the sale also varies. So with this we are able to understand, yes, keeping the items in different position of the shelf does have an influence on the sales. If you keep the item in the front shelf, the sale is very high. Just by looking at this value itself we can understand. And okay, and with this we are able to understand, right? Even with this test we are able to reject the null hypothesis, and we are going to conclude, yes, this is the one, okay. Fine. So what we will do is, it's already 10:45. So we will continue the chi-square test tomorrow, and also we have something called post-hoc test, which we conduct as part of the Anova test, okay, and that also we'll discuss it. After chi-square test we will jump into the introduction to machine learning, okay, tomorrow. Any questions so far? The table also I will show you, don't worry, okay. The chi-square distribution I will show you tomorrow. See, the hypothesis testing, right? So we define the null and alternative hypothesis for all kind of tests, okay. Anova test, even the case of chi-square we are going to test it. And here you asked, right, this question, whether type 1 error, type 2 error is applicable here. Now you tell me whether type 1 error is applicable or not here. Type 2 error, right? Since we are going to define the null and alternative with this, the same thing is applicable here also, okay. Any other questions? Okay, since you don't have any questions, I'm going to wrap up the session now. And please watch my videos going forward. Don't postpone it. Okay, fine. So we'll upload the video shortly, and we will circle back tomorrow, not same time. Tomorrow we will meet up by 5 p.m. evening, okay. Instead of on night, we will have it 5 p.m. tomorrow, okay, as an exception. Sorry.